Today's lesson is a continuation of section 5.1, right linear equations in slope-intercept form. Previous lesson we started talking about how in chapter 4, many times they gave us an equation, and then we took that equation and made a table or made a graph, or we went from one representation to another. That's what we've been doing a lot this year. This chapter is no different in this section, 5.1. But now what we're starting to do in chapter 5 is they're going to give us other information, maybe like some points or the slope or the y-intercept or a combination of those things, and then we're going to use those things to make the equation. We used to get the equation, now we're going to try to make them ourselves here given different information. The easiest equation we know how to make is slope-intercept form, or an equation in slope-intercept form, because we just need the two things that are in the name, the slope and the y-intercept. The slope stands for m, or the slope is the variable that stands for m, and the y-intercept is the variable that stands for b. So if I can figure out those two things, I can make an equation in slope-intercept form. Again, we started talking about this last lesson in a problem where maybe they just say the slope is -1 and the y-intercept is 1, and we have to write an equation. Well, then again, this is the easiest form of the equation we know. Maybe we can write something like that if we know the slope and the y-intercept. In this problem we do. So I just plug those numbers in for m and b. M stands for slope, so if the slope is -1, I'm going to put -1x. And if the y-intercept is +1, well, then I just put +1. And if I want to simplify that, I can also just write negative, I don't even need the 1 in there, but just -x plus 1. We could also see this as well. So either of these ways is actually right, but that's all we do is we can find those two things, the slope and the y-intercept. I can make an equation. And in some of the problems, they will just give us that information right up front. Number 2 here, same kind of thing. The slope is 1, the y-intercept is -9. So if I'm going to make an equation in slope-intercept form, the slope is 1, so I could put 1x, or again, if it's 1, I don't even need to put a 1 in front. I can just put x. And then the y-intercept is -9, so I'm going to put -9. So the equation for this one would be y equals x minus 9. We also did some problems where, as opposed to just giving us the slope and the y-intercept, they gave us a graph of some line, and we can make an equation from this as well. Remember that if I'm looking at the graph of some line, I can find the slope and the y-intercept just by looking at a few of the key points. For one, so let's say we're going to find m and b, the slope and the y-intercept. Well, for one, the y-intercept is just the point where the line crosses the y-axis. So here's the line, and then here's the y-axis straight up and down. So this point actually, 0, -4, that is the y-intercept. That's the point where the line goes through the y-axis. So I would say that the y-intercept is -4. It's just down 4 from the origin. So if I get a graph, I can usually pick that out right away, but just by looking at that key point on the graph, where the y-intercept, or sorry, where's the y-axis and the line, where do they intersect? To find the slope, remember there's two different ways we can do this. One way is by using the subtraction method we know. I can take the two y coordinates and subtract them. So I could do like -2 minus -4, so I'd have to chop there. And then 7 minus 0 and put that in a fraction. And in this case, well, it looks like I'd have 2 over 7, so my slope would be 2/7. And to make the equation, I have m and I have b now, so I can just say y equals 2/7 x minus 4. We can also, if we have the graph, remember we know these 2 points on the graph then, so I can also just figure out the rise over the run of this line between 2 points. How far do I go up and how far do I go to the right? And I can put that in a fraction. It's the same idea as doing the subtraction to find the slope here, just like this. In this case, it looks like I go up 2 and I go over 7, so what do you know? That's my slope, which is what we found out already, 2/7. So again, I could do it either of those two ways. If I have the graph, the way I have here in red is handy, but if we don't have the graph, well then it still works just by doing the subtraction to find the slope like we've done in the past. Subtract the y-coordinates and the x-coordinates. That second method is going to come in much more handy today because there'll be problems where they don't give us a graph, but they do give us the 2 points that the line goes through. So for example here, the directions for this one say write an equation. So we're going to make something like y equals mx plus b, because that's the way we know how to do it right now. Write an equation of a line that passes through the given points. So again, problem 1 here, it says that there's a line that goes through these 2 points. If you don't have the graph, but you're a visual learner and it does help to see some kind of picture in your mind or some kind of visual for this, again, you could make a little graph, and that's totally okay with me. You could do that on the homework or just off to the side on scratch paper, but either way, that or on some graph paper. 1, 2, 3, 4, 1, 2, 3, 4, 5. This point 4, 5 would be right here. The point 0, 2 would be right here. And so if you just wanted to get a little picture of what this is going to look like, there you go. You could make a little graph, and that's okay with me. I would like you to get to the point where you don't need to make a graph, but there's nothing wrong with making a graph to help yourself out to make a picture. So that's always acceptable. But let's say we're going to try to do it without the graph. So let's see if we can figure out a way. Well, the nice thing about this is there is a way. We don't need a graph to necessarily do this, okay, as long as we can see how the numbers work together here. Remember to find the slope. If I want to find the slope of a line and I know 2 points that this line goes through, just like we did in the previous page, I can just subtract the y-coordinates and subtract the x-coordinates, and that will be my slope. So in this case, 5 minus 2. So I'd take 5 minus 2, and then since I started on this point and went to that point, I have to do the same thing for the x-coordinates, so I have to do 4 minus 0. What would I get? I get 3 over 4 in this case, so my slope is 3 over 4. Well, here's the trickier part. At least you could think it's tricky right away, but what about the y-intercept? What about the b? On that previous problem, going back to the previous page for a second here, on this problem, what was nice is that I had a graph so that I could find where the y-intercept is. It was just this point, because here's my line, and then I know the point where the line crosses the y-axis. So then it was easy to find b. I could just look at the graph and spot it. Well, again, if we don't have a graph, we don't have that nice picture. But if you look at these points carefully, 4, 5, 0, 2, one of these points actually ends up being the y-intercept if you think about where they're both plotted. 4, 5, again, I'll draw my graph for my picture one more time with this. 4, 5 would be somewhere up here. 0, 2 means you go left or right 0 or up 2. So this point right here, this is the y-intercept. It's just 2 up from the origin. If I graph this, again, where does my line go through the y-axis? It's right here at positive 2. So we're going to notice today in this assignment is that often they're still going to give us the y-intercept. We just have to do a little bit of thinking and realize that if there's a point 0 and then something, that something is our y-intercept, because it means the 0 means we haven't moved left or right at all to plot this point, but in this case we've gone up 2. So the y-intercept is positive 2. In the future, they'll take that away from us as well, and we'll talk about then how can we find the y-intercept if they don't give it to us in the problem. But for now, if they're going to give us the y-intercept as one of the points, we'll take it and we'll say, okay, my y-intercept is just 2. So if I'm going to make this equation, the slope is 3/4, so 3/4 x plus 2. Move on to this next one, same type of deal. I'm going to make some equation in slope-intercept form. So I need to find the slope and the y-intercept. I need to find m and I need to find b. To find m, just like we've done in the past here, I can do the subtraction. Let's say we'll go this way this time. -1 minus -2. I'll have to chop. And so if I go -1 minus -2, then I got to go 0 minus -3. Chop as well. The slope for this one then. The slope for this one will be, let's see, -1 minus -2. I chopped it. I'm going to add. I'm going to end up getting just positive 1. And then 0 minus -3. So I also had a chop there. I'm just going to get 3. So I'm just going to get 1/3 for this, positive 1/3. For the y-intercept, again, if I look at these points carefully, -2, -3, well, that'd be somewhere in the third quadrant, because they're both numbers are negative. But if I look at this one, 0, -1, that point is the y-intercept. I go left or right 0 and just down 1 to plot. Again, just a little picture to help here. This point, where would you go? You'd be at 0, but you'd go down 1, so it'd be right here. So this graph, whatever it looks like, maybe something like this, okay? But here's my y-intercept, that point, -1. So in this case, my b is -1. Then I have all the information I need to make an equation now. Y equals 1/3 x minus 1. Trying just a couple more examples here to make sure we have the idea. Here's examples 3 and 4. Again, it says, the directions might say something like write an equation of a line that passes through the given points. We're going to learn how to write equations in a couple different forms. But for now, we just know slope-intercept form. That's the most popular one anyway. So that's the one we're going to use the most. So that's the one we need to learn. To write one in slope-intercept form, I need the slope and the y-intercept. So I need to find what m and b are. M equals b equals. Well, again, m, what do? To find the slope, if I know 2 points that go through the line, I can just subtract the y-coordinates and then subtract the x-coordinates, and that'll make my slope 5 minus 1 over 0 minus 8. In this case, that gives me 4 over negative 8. If I reduce 4 over 8, that gives me 1/2 for a fraction. And since one of the numbers is negative, I have one negative number in this problem. That means that my fraction is a negative slope. So negative 1/2 is what I end up with after I reduce. Looking at those 2 points, 0, 5, 8, 1. Which of those is the y-intercept? It's going to be this one, 0, 5. Because if I plot that point, it'd just be left or right 0, so I'd be right on the origin still. But then I'd go up 5, and I'd put a point. So that point is the y-intercept, because we're saying this line goes through that point, so that has to be it. So my slope is negative 1/2. My y-intercept is 5. Making an equation in slope-intercept form, then I have negative 1/2 x plus 5. Last example I have on this page, number 4 here. I'm going to make an equation in slope-intercept form. I'm going to pick out m. I'm going to pick out b. To do that, I got to find the slope first. I'm going to subtract the coordinates. Let's say 8 minus negative 4 in this case for the y-coordinates, and then 4 minus 0 for the x-coordinates. And if I subtract those, I'm going to get 12 over 4. Again, just showcasing this too. Something we've talked about in chapter 4 as well. Well, what if I subtract them the other way? Some people might be asking. What if you instead go negative 4 minus 8? Okay. Will I still get the same answer? Okay. Well, just showing you that, yeah, we still will get the same answer. It doesn't matter which way you go. Whether you go one way and your neighbor goes the other. You just have to stay consistent with how you do it. So in this case, if I started at this one and went to that y-coordinate, then I also have to start at this x-coordinate and go to that y-coordinate. I always have to start with the same point and go to the other one. So I went negative 4 minus 8. So now I got to go 0 minus 4. So what do I get? Well, I get negative 12 over negative 4. The other way, I just got positive 12 over positive 4. So again, just showing, yeah, you do end up getting the same answer because negative divided by negative gives me a positive anyway for this one. And I've got this in the way, but negative divided by negative gives me a positive. 12 divided by 4 just gives me 3. And the other way, it would have gave me 3 as well. So just remember, it doesn't matter which way you subtract them, just as long as you stay consistent with however you do it. Then looking for b, looking for the y-intercept. Well, that'd be this point in this case, 0, negative 4. So my y-intercept is negative 4. So this equation ends up being 3x minus 4. One more thing I want to show you in this lesson is just a reminder that function notation and equations, they're very closely related. In fact, they're almost the same thing. It's just that sometimes when we use function notation, we write an answer one way. When we find answers in an equation, we write them a different way. But otherwise, it's really doing the same exact thing. So just kind of showing that because there will be some problems today and problems in the future that do this for us. Here's an equation, y equals 5x minus 2. Here's a function, f of x equals 5x minus 2. Remember that when we were working with equations, first of all, when we worked with equations, we had one method for graphing where we used ordered pairs, where sometimes we would make a table and we put in numbers, maybe let's say like 0, 1, and 2. And that means when I put 0, 1, and 2 on this side of the table, that means that I'm going to put those numbers in here for x and then evaluate and find the answer for what y would equal, or just what the answer is after I've evaluated. So let's say I put 0 in for x. That means I would take 5 times 0 minus 2 and see what I get. 5 times 0 would give me 0, minus 2 would give me negative 2. Okay? If I put 1 in for x. Again, remember, this is just a kind of a review almost of ordered pairs, but I'll show how it ties in here in a second. 5 times 1 gives me 5, minus 2 gives me 3. If I put 2 in for this problem, 2 in for x, 5 times 2 gives me 10, minus 2 gives me 8. So remember, we did things like this where I can find ordered pairs. I plug numbers in for x, and I get answers out for y. Well, remember in function notation, okay, this also, we do the same type of thing. We just write it a little bit differently. If I want to put numbers in for x, like plug in, let's say, 0 and 2, just those numbers, but you can put in 0, 1, and 2 as well. But let's say we're going to work with 0 and 2. Remember, there's a way to say that in function notation. We write f of 0. This means in the function f, I'm putting 0 in for x. And so just like we did earlier, just like I did above, I put 0 in for x. 5 times 0 gives me 0. And then minus 2, and I could find what my answer is. Same thing here. This is saying f of 2. This means in the function f, I put 2 in for x. And you can kind of see where that is, right here. So then I put those numbers in, and I find answers as well. And what do you know? As I kind of showed down here, I get the same answers I did as with ordered pairs, right? If I put in 0, f of 0, I got negative 2. Well, isn't that just like the ordered pair up here, 0, negative 2? It means the exact same thing. I put 0 in for x, and I got 2 out, negative 2 out for the answer. Same thing right here. F of 2 equals 8. Well, up here I found an ordered pair that was the same exact thing where I put 2 in for x, and I got 8 for an answer. So just realize that when I'm using function notation, okay, what I want you to get out of this, I'm using function notation, and it looks something like this. It's just like saying the ordered pair 2, 8. So when you see an ordered pair in function notation like this, I can also just think of this as 2, 8. And same thing with this. I can think of this as like 0, negative 2. Because that's just what it's like when it was when our table up here as well. Just like an ordered pair where x is the x coordinate and y is the y coordinate, and those numbers go together. Again, I show this because there'll be some problems even in today's assignment where, or in the future, where we see ordered pairs in function notation. But just realize it's the same as the problems we were doing on this page right here. When I gave you 2 ordered pairs and I said, okay, find the slope, find the y-intercept, find m, find b, and we did that, right? Well, if they give me the ordered pairs in function notation, it means the same thing, like I was showing on the front page. This means you put 0 in for x in this function, and you got negative 2 out as an answer. Well, that means it's just like the ordered pairs, 0, negative 2. Like when I put 0 in for x and get negative 2 out for y. So I can just write that instead, and maybe it makes a little more sense or is a little easier to understand. This one also means I put 8 in for x, and I got 4 out for y. F of 8 equals 4. But that's what that's saying. I put 8 in for x in this function, and I got 4 out for an answer for y, or just for the answer of the function. But it's just like 8, 4, that ordered pair. I put 8 in for x and got 4 out for y in that case. And so if I just think of these ordered pairs in function notation, I can change them just to look like ordered pairs like we're used to seeing, and then I can still find the m and the b, the slope and the y-intercept, just like we were doing before. 4 minus negative 2, 8 minus 0. I'd get 6 over 8, which would be 3/4. And so I could find my slope. And this point's my y-intercept, which is negative 2. So I could still make the equation 3/4 x minus 2. But realize this. So this is just like we did in the previous pages. But instead the points were just in this function notation. So when we see that, we shouldn't be too intimidated or too worried. Same thing, I'll just kind of show it for number 5 here. I won't go through the whole problem, but same thing with this one. If it says f of negative 3, that means in the ordered pair they put negative 3 in for x, and they got 6 out for y. So that's like the ordered pair, negative 3, 6. And f of 0, 5 is like the ordered pair where they put 0 in for x and got 5 out for y. So just know when we see function notation, it's just like ordered pairs like we're used to seeing. And in fact, I'll tell students today, they should write them like that, because I think that we're used to seeing that for a long time, so that won't confuse us as much. If we can handle it for function notation, sure. But otherwise, you can just write them like this, and this means the exact same thing.